Welcome, everyone, and thank you for joining us today. Today, we're here to talk to you about cars. Well, I should really say connected cars. Let's make that connected vehicles. Better yet, telematics for connected vehicles, communication systems for connected vehicles, analytics on connected vehicles, and securing connected vehicles. Let's turn to today's featured speakers. Christine Caviglioli is the Automotive Vice President for Thales Analytics IoT Services. She will share the state of the connected vehicle industry and present a number of high-value 5G connected vehicle use cases. Damien Black is the Vice President of Business Development at Guavus. He will share how to use artificial intelligence and machine learning analytics to deliver real-time 5G connected vehicle applications. Eric Leibowitz is the Chief Information Security Officer for the Americas at Thales. He will discuss the security challenges with the complex and vulnerable mobile networks and connected vehicles, and what communication service providers and automobile manufacturers need to do to protect against security threats. Eric's practice of security is so strong that even his webcam is unable to show us his video today. But that won't be a problem because his audio is crisp and his presentation is strong. You may have or think of some questions during the course of the webinar. Please be sure to ask them via the webinar chat system. We look forward to addressing them during the Q&A session. If you experience any technical difficulties using a web browser-based client, remember, you can always refresh the page to get back into the webinar. Also, we will offer some poll questions during the session. Don't be surprised when your GoToWebinar screen presents one of them. We'd really appreciate it if you could participate in our polls, and we promise they will be fun. With all of that said, I'd like to ask everyone but Christine, our Automotive Vice President for Thales Analytics IoT Services, to turn off their video and audio. Christine, the floor is yours.
So I will talk about the road to 5G and how this works within the driving car connectivity. I would like to share my first experience. When I started to be involved in IoT machine-to-machine, it was in the early 2009. And I started working on connecting cars. And for that, the network that were deployed was a 2G network. Since I have seen 3 different networks deployment, 3G, 4G, and now 5G. While during the same period, we estimate that only 50% of the new vehicles are connected, just to show how it takes for a car to be connected, and that at the same period, we have seen 4 different network deployments. But we see that the connected car is just becoming to be one of the fastest growing manifestation of the Internet of IoT. So for sure, with the support of 5G, we will see very quickly to have almost all the car connected. The focus is really to see an ever increasing autonomy and experiment. The car is still making what we say the revolution. The focus is new and major innovation, transformation, and experiments moving to the autonomous cars. But this will only happen if we increase the connectivity by making the right turns in terms of network infrastructure. One question, do you know how many countries have launched 5G today? When we do a quick round, we see that 21st country have started deploying a 5G network, which is not a lot. And we see that this is very much led by US and China. But when initially the previous iteration and deployment of 4G and 3G technology were more developed within a consumer approach, 5G will have a further rich impact and the number of use cases within the industry, and clearly one of them being the automotive industry. So when we are looking to 5G, and we will go now into a more detailed approach of what are the value and the technical asset of 5G, we need really to think about the value of the network within the industry. Indeed, with this increased spectrum use, 5G will position to deliver higher bandwidth and low latency, which is very important for the automotive industry, and I will share some examples. But also it will help to set advanced features and services that will improve the on-road experiences for the driver and the passengers. And clearly the self-driving cars. But the 5G in the automotive industry also provide the ability to increase information provided to in-car system that we will download to the car, but also upload from the car. So the 5G will help to manage the data. So according to the different technical standards, the 5G infrastructure that hosts solutions and applications that are on board the vehicle must really deliver and reach some technical standard. The first one is the network slicing, which is now allowed by 5G. By slicing part of the spectrum for specific use cases, we can provide continuous services for critical device and time-sensitive data. With that, we will ensure that the reliability needed for having automated vehicle will be reinforced. So that means that we will provide a good service quality and a strong level of security. But not only the network slicing, the average data speed, which is very important, it estimated for a 5G network in terms of speed in the range of 20 gigabytes when we are talking about downlinks and 10 gigabytes for uplink. However, 5G download speed may differ widely by areas. We have experienced that in some areas like Las Vegas, we have 220 megabytes, and in some other country like Minneapolis, we can have up to 950 megabytes. So also depending on how do we deploy the network, we can see some differences. So this is very important also when we want to push for some services. A fourth feature is the latency. 4 milliseconds is typically the condition that we can operate for the network, but we have seen that for some use case, we need to be below 1 millisecond latency for use case that really required the utmost speed. For example, low latency is very important when we want to remotely pilot a fleet of autonomous cars or for services for driver assistances. In that case, a connected car have to make decisions in real time, such as bringing car to stop if pedestrians cross the street. And in order to avoid life at stake, we really need to make sure that the connection must be continuous and reliable. The last but not least, it's about network coverage. As with 4G, the majority of 5G infrastructure will initially be concentrated in built-up areas, in cities, highway. So it's very important that for the automotive industry, it's that a large proportion of driving occurs in rural areas. So that means that 5G access must be enabled also at the major points of the road infrastructure. Drivers will not be satisfied with features that only works in urban area. And this brings me to talk about the V2X, because how then we will go into V2X environment if we are not able to deploy a full 5G network. So shall we completely forget about V2X in countryside? I don't think so. Why that? It's because moving forward, I really want to clarify one point. We always associate 5G with V2X, but V2X already exists on 4G. So why do we link both 5G and V2X? The reason why is that the cellular V2X will be ready at the same time 5G will be massively deployed. So we keep thinking 5G will enable V2X deployments. But V2X, except for V2N, vehicle to networks, rely on what we call direct vehicle communication. And then we don't need cellular network coverage. So we will need cellular coverage when the car is talking with the network in order to upload data. But when you want to share with the infrastructure, vehicle to pedestrian, vehicle to vehicle, or vehicle to infrastructure, you don't need to have a wide network coverage. So to take some example, V2P is not yet mature enough to provide detailed use case, but V2V and V2I are. So let me give you some example of V2V communication. V2V communication will help to avoid collision in difficult weather conditions or poor visibility, or when other system fails, thanks to the ability to share information from one vehicle to another, with also transmit the vehicle location. So this is one of the use cases that will be for sure implemented on the V2V. About V2I use cases, this is the infrastructure. The I is for infrastructure. It can relay information in case of accident that will be displayed within the screen in the vehicle. This is what we call the signal phase and timings path, which help really to ensure traffic management, is the traffic management, providing information through the red light display. So these are some examples of use cases that we can see within the V2X, but are not completely reliable, but more often we associate to 5G. Then talking about the value-added services that connected car bring. Also, the full autonomous vehicle is not a reality for consumers yet. We can see the connected car is. We can say only half of the car are connected, but since I have been working within this landscape for more than 10 years, there is today a clear status that the car is connected. After, it's just a question of deployment of connected car. So more and more ECU, electrical control unit, with new functionalities are embedded in vehicle, and then the connectivity is really becoming a key features for manufacturer and OEM, and it's really the foundation of interaction and communication between the vehicle and in its environment. Will it be the consumer, we have seen the cities, the cloud. So we see that the car is more and more connected. So 5G will be important for vehicle users, because by having this car connected, the user will benefit of new services. So we will be able to provide in-vehicle application downloads. So we can experience already many applications download in your car, up to payment application, stream entertainment, firmware update. This will lead consumer to expect for sure that a reliable data connection. 5G will enable also additional use cases. We have seen in-vehicle entertainment, such as real-time like video streaming, driving experience, autonomous vehicle, self-driving, real-time road monitoring, free parking slots. So from over-the-air update to enhance the overall driving experience, the amount of data consumed will really increase exponentially. Overall, connected car will generate more than 25 gigabytes per hour, coming from data from ECUs, we have seen, from videos, from location, and also from V2V or V2I, such as driver behavior. So sending, receiving, and analyzing this data will require a vast bandwidth. Then what does it mean in terms of end user? So having an optimal and uninterrupted connectivity in all circumstances determine really the driving quality and the service offered to the user. Connecting car to smartphone, to each other, and to external infrastructure is already done, and this is what I said. However, we really need that the connected car should succeed in meeting fundamental customer needs. What are they? Security, safety and protections, safe timing and money, comfort and entertainment, insurance and maintenance. So with the car connected, we will see also new services like free parking, emergency call system, driver insurance premium, all these new possibility and new offers that will pop up in your car. So what we see as a trend that we experience is really the convergence with the consumer digital habits that we pop up into the car. Consumer electronic devices, which is interacting with the vehicle, Wi-Fi hotspots, but also Apple and Google convergence. So this is, before we have seen a lot which is very much linked to the car and the car services. And we see also that with the car being more and more connected, this convergence with consumer habit. And also we can consider that we are working into an extended vehicle as your second smart device. We will be able to gather real-time information on traffic, parking space, receiving, as we say, your agenda in order to improve your journey planning. Voice assistant, smartphone integration, as we mentioned, make payment, location. So many services that will be able to operate from your car thanks to this huge and thanks to the 5G network deployments and these new features that we can rely on. So what we have seen is that as an open platform, for sure, and that will integrate many solutions and applications, the need for seamless and high quality connectivity is very important. But it's a challenge and a must for the connected vehicle. But on the other hand, with a car being hyper connected, this means that we'll have much more data to manage, more services to integrate, and also be the source of security breaks and potential attack vector for hackers. So a lot of hope, but we really need to see what we will do with all these services, this data that we will get from the car and that we will push to the car.
Thank you, Christine, for sharing those provoking thoughts on 5G networks, connected vehicles, and the value-added services that we will all see in our automobiles in the future. Let's shift gears with a poll question. Would you watch a movie while in the driver's seat of a self-driving connected car? It looks like 71% of you would not do that. Well, I'll say to you, I'm happy to see that you all have your heads screwed on straight because I feel exactly the same way. All right, let's welcome Damien Black back, our next speaker. Damien is the Vice President of Business Development at Guavus. He will share how to use artificial intelligence and machine learning analytics to deliver real-time 5G connected vehicle applications. Damien, the floor is yours.
Thanks, Adan, and thanks, Christine, for your talk. I'm going to talk today a little bit about artificial intelligence, machine learning applications as applied to cars and vehicles, and how they may actually change and be enabled and adapt to the world of 5G connectivity. So one of the areas that that we're working with a lot is in smart maintenance, where we're trying to apply the continuous analysis of data to try and perform some sort of intelligent predictions about what will happen to the vehicles, devices, engine, components. The difference between smart maintenance and the past traditional maintenance approach, which was traditionally reactive. So when you have the cars, when you are running your analytics on the actual vehicles, you have the predictive algorithms that are running, trying to process the data that's coming from the car. One of the first things that as a designer of these systems you have to consider is how much it's going to cost to get all of the data back to the cloud if you want to do the processing of the predictions and the data on the cloud versus what you're able to do in the car itself. And there's a clear, trade-off here between the cost of the compute that you're going to build into the vehicles themselves versus obviously the flexible, elastic compute that's available on the public cloud or even in private clouds. So you will go through those trade-offs and try and find the optimal way of splitting the processing so that some of the pipeline processing can be done on the actual car itself, other data is sent off and processed in the cloud. The other element of this is actually the latency that's required. for operations where you want to be able to process stuff in real time or close to real time, clearly you don't want to have to go through the unnecessary delays that send you through going into the actual cloud itself. So the round trip there can exceed add into dangers with regard to looking after your actual vehicle. So let's move on to the next slide. So as we're building these machine learning models that are analyzing and processing the data, one of the things that we can do, again, with sufficient compute capability on the vehicles today, vehicles that are powerful enough to support these 5G communications have also got quite a lot of computing capability built into them as well. So what you have then is the situation for the car models, the machine learning models, to be able to process data locally and to be able to adapt and control the data that's coming in, so that each model can be customized and localized to that specific vehicle. So based on, for example, the driving conditions in your neighborhood or your part of the world, the weather that you're experiencing, the kinds of road and traffic that you run into, and your driving style, whether you're heavy on the brake or heavy on the accelerator, you can get an adaptive model which might help with regard to providing preventive maintenance or security, safety alerts during the actual processing that will continue continuously. And it will be created as a local model. You click onto the next. And so what happens then is you then can have these models that are where the deltas, just the incremental differences. So you starting off with a baseline machine learning model. As you localize that model based on your local conditions, just the deltas you then transmit up to the cloud over the 5G network. And then all of these vehicles, each of which are then sending up their local deltas, those deltas are analyzed and compared. And where there are trends in the cloud that can be spotted, where a number of the same kind of components, improvements have been made to those models, they can then be aggregated through a voting mechanism to create a new baseline model that then can be pushed back down to the vehicles. And so through this kind of mechanism, you have a great way of actually having localized models, but sharing those models back through into through to the public cloud, through the connected world, and then getting periodic new baselines that will improve the driving experience for all drivers. Next slide. And click one more time. We'll get the video moving. So when these cars, of course, are connected, one of the things that you can get from them is precise location. You get the ability to be able to combine all of the information from connected vehicles to form a much more accurate view of the real-time traffic world. And one of the applications we've built in the past, here we're able to actually segment traffic resolution down to 10-meter road segments and be able to detect, for example, all areas on the road network where vehicles are stopped or slowing down, or where they are accelerating, and with pinpoint accuracy. So you get a real-time view of exactly what's going on in the road segment, the traffic, you get a real-time view of your travel time, and you have the ability to be able to get alerts and alarms in terms of how your current driving experience is different from that which has been predicted, for example, earlier on during the day. We click one more time. And here we're showing the integration of social information at the same time. As these cars provide more granular information, click one more time. Here, in the past, we've actually already got some state-of-the-art applications where we're monitoring cars, vehicles, actually, and even pedestrians going through intersections using LiDAR technology. So processing the real-time location and integrating the paths of these vehicles as they go through intersections. As we do this with the V2 infrastructure capabilities that are now emerging in this 5G world, we'll be able to get a very accurate view of what's happening in the intersections themselves. Once you know the paths that vehicles travel through the intersections, the speed that they're going through, then it becomes possible to start performing global optimization of traffic light timing so that you can ensure the maximum throughput of traffic through a city through the right synchronization of traffic light timing, and also accommodating anything that happens with emergency services. Let's click one more time. Click through. Next slide. And we're talking about emergency services. We click one more time. Here we have an application where we are processing 911 calls in real time, again through the this case it's the 3 and 4G network, but you, obviously the 5G network will be in the same situation. So in this scenario, what we have is obviously real-time information from all people that are performing emergency services calls. If you have accidents on the road, you will immediately, they'll be informed about where the location is from that particular accident, and that will be then fed into the overall analytics that are looking at exactly the state of the emergency call service. For example, how long is it taking to answer a call? What is the queue buildup? How many calls get abandoned before they get answered? Where those calls are happening in real time on a map, and any of the critical analytics that will give the emergency services views in terms of the best path and route to reach you in your car, and to get a good idea of if there are any larger situations that are happening, such as perhaps an explosion, some terrorist attack, or some major pileup on the freeway, where that will be spotted as a concentration, a clustering of emergency calls coming out at the same time. So the world of these connected vehicles is going to change dramatically as we bring together the capabilities of artificial intelligence, real-time location, real-time tracking, and the connectivity between cars to vehicles, cars to cloud, cars to infrastructure. And that concludes my part of the presentation.
Thank you, Damien. Those real-time visualizations of vehicles and calls really speak for themselves. So it's time for another poll question. Would you trust a machine-connected ambulance to get you to the right hospital? And the results are like this. 69% say yes, and 31% say no. And I guess my concern is that you all might need an ambulance to get you to the hospital from your ambulance with that sentiment. But that's just my view on it all. I'd like to welcome back Eric Leibowitz, our next speaker. Eric is the Chief Information Security Officer for the Americas at Thales. He will discuss the security challenges with complex and vulnerable mobile networks for connected vehicles and what CSPs and automobile manufacturers need to do to protect against security threats. This is clearly a very important topic.
As Eden said, my name is Eric Leibowitz, and I lead the cybersecurity program for Thales in North America. The first two presenters, I think we heard a lot of interesting things about connected vehicles, smart cities, and what I wanted to do is share some thoughts on the security aspect of this topic, because that's where my mind always goes. So let's jump in. So I started thinking about the term Internet of Things, as we heard it a couple of times here in the presentation already. And I went and looked up the history, and it sounds like the phrase was actually coined back in the late 90s, but didn't really start to gain popularity till probably about 10 years ago or so. If you look up the definition of Internet of Things on Wikipedia, it's defined as things, and I'm using air quotes here, but you can't see me, but things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices over the internet. Sounds pretty straightforward. So by that definition, the Internet of Things could be my refrigerator, could be a light bulb, a smartwatch, or as you heard earlier today, even your vehicle. So I remember hearing probably 7 or 8 years ago about the first Wi-Fi light bulb and thinking to myself, no one's ever going to buy one of these. Why on earth would someone pay 5 times as much for a Wi-Fi light that does the same thing as a regular light bulb, but can be turned on and off via an app on my phone? Big deal, right? Well, that question was answered when these devices went from simply being a device on my Wi-Fi network to becoming a smart device. I think when that happened, devices became much more appealing to me and to a lot of other people. I realized that they could be turned on and off with my voice at a specific time of the day or night, or when I simply walked into or out of a room. Before I knew it, just about everyone I knew had some sort of smart device in their home. Some have just a couple, but some of the more tech-savvy people I know have quite a bit more than that. So I'm even willing to guess there's probably a number of people on the webinar today that have more connected devices that they can count unless they actually sat down and did some type of inventory. So is this a good thing or a bad thing? And I think the answer is yes, both. It's good that these devices can make life easier and often save time and money. Prices have come down significantly in the past few years, so they don't cost a whole lot more than the standard version of the same product. But on the bad side, the important question is, are these devices actually secure? So we need to ask ourselves, am I the only one that has access to them? Can someone else change the temperature on my refrigerator and ruin all the food I have in there? Or turn my lights on and off all night long, or worse, look through one of my security cameras? I think it all comes down to how seriously the device manufacturers take security. So let's talk about what the word connected really means in terms of security. I'm sure the majority of people on the webinar today have one or more of these popular smart home hubs in your house. They become really inexpensive. They've become even stylish so that they hardly stand out from the normal decorations that you'd have in your house. Some are just plain devices, while others have screens that show your photos, local weather forecasts, and even your traffic on your commute to work, if anyone's still commuting to work these days. So you could ask these device questions and get endless amounts of information, play games on them, use them to control your other smart home devices like I mentioned earlier, and you can access them from anywhere on the internet via an app on your phone. So how are they able to do all of this so quickly? By always listening. So these devices have to be in an always listening mode to be able to hear the specific word or phrase that begins your official interaction with them to get the service that you're looking for. I think the catch here is they can only do this by listening all the time for that phrase. And all the popular smart home makers like Google and Apple and Amazon, they'll give you ways to look at the history of all the recorded requests that you've asked them to do over time, but they don't actually show you what conversation they were listening to prior to initiating them with that specific catchphrase. Now, they'll all claim that they don't store any of these recordings, and I'd love to believe it, but I'm sure you guys, just like me, have read a couple of articles over the last few years of how some employees have, or third-party contractors have had access to some of these recordings to improve their capabilities. Get another air quote there. So I'm not saying that we shouldn't have these devices in their home. I do, right? I love them. I use them all the time. What I would suggest is that you stick to really the top most popular device manufacturers like the ones on this slide, especially when you're choosing a device that's going to be in your home, always listening. Reputable brands, there's a better chance that they're going to be more responsible with your data than some no-name brand that had a device that was made in some country far, far away. So I think security is really important here too. Most of the top device manufacturers spend a lot of time and money into making their devices secure so that people will have confidence putting them at home, right? You have to trust them if you're going to put them in your house and have them listen to your conversations. Unfortunately, not all device manufacturers take security seriously. And I don't think it's any secret security can be expensive. And if you want to get a competing device on the market quickly, we've seen companies cut corners when it comes to things like security. And unfortunately, it's difficult to build security into something after the fact. So if you buy something today, don't expect it to become significantly more secure over time. So after talking about some of the risks associated with Internet of Things devices, there's the real possibility that someone aside from you can gain access to your smart devices and possibly control them, right? We mentioned that earlier. It's not a big risk in most cases, but it's a concern to me. But what if I told you that they could also potentially be used to steal data? Again, not a common thing that most people need to be concerned about with most smart devices today, because these types of devices don't really have sensitive data on them. I wouldn't expect any sensitive data on a light bulb or a toaster that's connected to the internet. But these devices are connected to our home networks, and that means there's still a small possibility of someone gaining access to our network through one of these devices. I think the picture I have up here is actually taken from an article from a fairly popular news story I read a couple of years ago, where there was a casino in North America that was hacked and had sensitive data stolen, all because of a fish tank. This casino particularly had a really nice fish tank in the lobby of their hotel, and the owner wanted to make sure that it was always the right temperature and that the fish always had enough food, so he didn't ever come in one morning and find a fish tank full of dead fish. Not an unreasonable request. So the problem is the solution that they implemented was to install an Internet of Things fish tank thermometer. This way they could monitor temperature and receive alerts anytime, day or night, anywhere in the world if something was wrong. Again, very reasonable request for something to want, but I think they tried to save some money by buying a no-name brand internet connected fish tank sensor And this device didn't have any real security in place. So it didn't take long for a bad actor on the internet to eventually find it and use it as a jump point to get onto the casino's main network. And once they were on the regular network, they took advantage of some other security vulnerabilities and were eventually able to find some sensitive information and then steal that data by uploading it back out through the fish tank thermometer up to the internet. It might be one of the most creative ways that I've seen for a hacker to gain access to a network and remove information almost undetected, because who's monitoring the fish tank, right? I don't believe the name of the casino was ever released for obvious reasons, but I thought this was a fairly interesting story to tell when we start thinking about the security of Internet Thing devices. So now that I talked quite a bit about what an IoT device is and what the risks are associated with them, I wanted to talk specifically about connected vehicles. You heard a lot from Damien and Christine about a bunch of different things on this topic, but what I wanted to do is really focus on the security. So to me, the benefits of connected vehicles are probably far too many to list here. I think that we've talked about them at length already, and there's dozens more that we haven't talked about. I think smart vehicles will continue to get smarter all along the way. In fact, I would say smart vehicles really started out as just safety features, right? Things like adaptive cruise control, where you have your car, you could set your car to go a certain speed on the highway, and it will drive that speed until you come up to a slower moving car in front of you. And then your car will adjust the speed and keep a safe distance from that car in front of you until that car either speeds up or moves out of the way. And when that happens, your car will go back to your preset speed. And they did this by putting things like radar and cameras in the front of the vehicle. Well, once manufacturers started putting cameras on the outside of the vehicle, it opened up a bunch of new opportunities. So soon you were able to add things like lane keep assist, where the car would notify you if you start to drift out of your lane without having a blinker on, or even in some models, the car will actually steer you and slightly correct you back into your lane. I actually had this feature on one of my cars a couple of years ago, and I have to say, you don't know how bad of a driver you really are until your car beeps at you every 5 minutes to stay in your lane. It's slightly embarrassing when you have passengers in the car, but still painful nonetheless. So now these features have evolved into things that are offered in late model vehicles all around, like automatic braking, collision avoidance, and pedestrian detection, like we talked about earlier. And I really do think these features will continue to improve to a point in the future where cars will be able to travel faster and do it safer with less and less human intervention. Maybe not self-driving, complete self-driving anytime soon, but I think we're getting there. I think this will also lead to less accidents due to things like driver distraction, looking at their phones, or maybe misinterpreting a situation in front of them. These are all really good benefits that I think we'll all start to see in the very near future. In fact, you have some automakers like Ford and I think Subaru who are starting to put some of these things like collision and pedestrian detection even into their base models. So even if you have the most basic system, the most basic car, you get a lot of these features by default. So let's consider some of the risks. And these risks are not a whole lot different from the risks we face with normal computing technology that we use every day. So just like normal computer hardware, smart vehicles are going to be susceptible to things like supply chain attacks. So depending on where the automaker sources their computer components from, there's always the risk that there may be a backdoor or a vulnerability built into the software that it could allow someone to gain access over the internet. And there's also a large market for vehicle modification. And today's day and age, a lot of the modifications that we see to vehicles are being done by reprogramming the onboard computers to make your vehicles faster or change parameters and add new features. And all of these things introduce potential risk for malicious activity. So I think on my first slide, I had a question that I asked, are connected devices really secure? And I think they can be, but there's some things we can do about it. And first things first, I think we need to make security easy for everybody. An example is about a year ago, I had a Ford F-150 that I was notified one day that there was an update to the onboard entertainment system. All I had to do was connect my truck to my home Wi-Fi network, click a button to update, and I would be good to go. Well, it took over 10 minutes of trying to figure out how to get my truck connected to my home Wi-Fi. It wasn't as simple as plug and play. I think our home networks now are more secure and more advanced, and my truck just had not caught up to that yet. So I had to go play around in some advanced settings, and I finally got it connected. Great. Once it was connected, I was greeted with a message that said the update would take about an hour to download, and I had to keep my truck running in the driveway while I waited, which I don't think is great for the environment or anything else. So But when I say we need to make this easy for consumers, vehicle updates need to be done over the air, over something like a high-speed network like 4G or 5G, like we've been talking about today. And they need to be applied at a convenient time for the driver. I think the last thing that we want is to get in our car one morning, start it up, and find out that our entertainment system is going to need 20 or 30 minutes to update. It needs to be seamless, just like it is with our smartphones today. And I think as more and more of the car's driving features are starting to be controlled by computers, we need to make sure that the connection to these features are only one way. So an example is Thales builds a lot of the in-flight entertainment systems that you see on planes in the seat back in front of you. So those systems have TVs, movies, and games, but a lot of them also connect to the navigation and telemetry systems on the planes so that passengers could look at things like altitude and airspeed and time to arrive at the destination. The risk of a passenger being able to tamper with any of the onboard flight computers is far too great to leave this to chance, so a lot of work goes into ensuring that this communication remains one directional. I think the same thing needs to be done with connected vehicles and smart cities. We need to work together as an industry and possibly even agree on a common security framework to follow. So frameworks like NIST and ISO, they've been around for many years, and we use them to secure even our most critical infrastructure today. So that might be an opportunity for us to look into that. I think we also should make sure that we're always following best practice, whether with any of our sensitive systems, IoT devices, or whatever. We should be using strong passwords and things like multi-factor authentication when connecting to them. We really want to make it as difficult as possible to give anybody unauthorized access to any of our devices. And just like computers do today, connected vehicles, smart city infrastructure, all of that, they need to make sure that they verify any updates that are made to their systems. And this will reduce the likelihood that any malicious code could be pushed to one of these systems that gives someone access down the road. So like I said earlier in the presentation, security really needs to be built in from the ground up. Trying to shoehorn security into a product after it's already been developed never works and always winds up costing a significant amount of more money. And then finally, we all need to work together to achieve this. So when I look at companies like Thales and Guavus, I think we need to work hard to continue to work with auto manufacturers of smart vehicles, connected cities, any internet connected devices, and make sure that we're always pushing the importance of security in all of their products.
Thank you, Eric. You have me thinking more about IoT security. In fact, I'm thinking I may go turn Alexa off in the next room after this presentation. I know you've been waiting for it. It's time for our third poll question. Would you be concerned that your connected car could suffer a security breach and get hijacked? It looks like 90% of you are concerned, and I'm going to take that to mean that you've taken Eric's presentation to heart, and I couldn't agree more with you. Now we're moving into our question and answer session. Please be sure to send your questions using the webinar chat. And we already have one that I'm ready to start with. It's a question from Carl Weaver. And Damien, I think I'll direct this one to you. Can't all the raw data collection and refinement be done at the edge and through the cellular IoT module before it reaches the cloud?
So in the presentation, I gave an example where you can, even if you do all the processing on the particular vehicle, for example, to improve perhaps the driving responsiveness model or the maintenance predictive models. What you also want to be able to do, though, is to get the benefit of multiple independent experiences. And the only way you can do that is to have those shared. The best way of sharing that is back through into the cloud so they can be aggregated together to provide a new baseline that's going to bring the best experience across multiple vehicles, multiple devices, so that you have something that then provides the benefit of individuals to everybody.
Thank you, Damien. I also have a question for you, Christine. It's from Surinder Gupta. And how many IoT sensors, devices, or gateways are compatible with 5G?
I think that it's not the sensor that are in the car, because everything, the data will be popped up by the TCU and will connect. So if you consider the sensor within V2X technology, this is no relations with 5G. And if you consider the information as a car is connected, is able to connect to a 5G networks, the sensor will, the information and the data we will gather from the sensor will pop up to the cloud. So for me, I will not mention about compliancy between sensor and 5G. Today, we are not talking that sensor are 3G compliant, 4G compliant, or 5G compliant. Sensor are within a car, and it's the car which is 3G, 4G, or 5G connected. So for me, this is more linked to the car than the sensor itself.
Thank you, Christine. I have a question for you, Eric. How do I know if my vehicle is connected, and how can I tell if it needs to be updated?
So I think every car manufacturer does this a little bit differently, but in your main entertainment screen, there's always going to be an option to go into settings, and more times than not, you'll see either the fact that it has a mobile connection over 4G or 5G or Wi-Fi that you can connect to your house, like I mentioned earlier. And typically you will get a notification on screen if the manufacturer is pushing an update. But again, there's always options in there where you can manually, just like on your phone, you could scan for an update to see if you have one. So just like I always say with my phone, with any of the other devices, computers that I use, it's always a good idea, maybe every couple of months, just to check and make sure there's not an update waiting, because a lot of times they don't just push feature enhancements, right? But there's also security updates and improvements in there as well.
Thank you, Eric. Damien, a question for you. There are many traffic systems available. How is your approach different or better?
So one of the things across many traffic systems is that they are hard-coded, and you have to basically live with the features that are provided by the supplier, such as Google Traffic, one of the most popular suppliers of this whole technology and system. The approach that we've been doing is to provide the actual description of all of the analytics and traffic in a high-level SQL-based language, which runs, it's very easy to modify. It's all of the actual logic and code is there. So it means if you want to build in customized features, customized alerts, customized analytics, it's very easy and straightforward to do that. So instead of the black box situation where you have to wait for a long time for anything to change, a customer can actually take the system, provide tailored analytics and alerts that meet their business requirements immediately.
Thank you, Damien. One more question for you from Carl Weaver. Can you discuss how AI is used within the cellular module when collecting data from the sensors to determine its integrity? Is the data set real, or has it been altered?
That sounds like more of a security issue in terms of actually being able to track whether the data is original or not. I think that's, Eric, is that something that you would like to take, perhaps?
Yeah, I would say, just like any type of software that we see, the manufacturer typically puts some code in there that will allow the device that it's being pushed to recognize that it's expected, it's the right size, it's the right content, so that the risk of somebody taking that information and potentially putting an additional line of code or some other parameters in there likely wouldn't happen. So I don't know specifically how that would happen. I would imagine that might take place, at the edge, like we were talking about earlier, just to be able to validate that data coming in is data that's expected and not just processing any data that comes into it.
Thank you, Eric. For you, Christine, how do you see the integration of connected cars into smart cities?
We have seen that 5G will bring always on and high-speed link communication between the car and its environment. For example, a global traffic management in cities will start to be possible because we can already provide some services like that. So we have mentioned that guiding cars to free parking slot is also something that will pop up, even if maybe in a longer term. So for me, we can really envision that we will see the traffic management for cars to be similar with what we see on railways and on air traffic system, that we will be able in a short medium period to manage the cars in the city, and for sure the autonomous car in the city, like we do today with the trains and the planes. So yes, for me, it's moving forward, and 5G will be for sure one big element for this.
Damien, there's another question from Surendra Gupta that I'd like to ask you. He's asking about what's going on with connecting transport platforms for rail and road. Are those sensors and devices connected to 5G?
Rail and road. So we actually have some insights right now into what's happening in some of the next generation metro rail systems, because we're in the middle of responding some of these RFQs so for some of the very first systems that will be going into production. And we're actually seeing for the first time now that for example, computer-based train control systems are looking to turn to 4G and 5G networks for all of the actual transmission of critical information, including critical safety information. So as trains enter stations, you want to know whether there's an existing train there, the relaying of all of the information detected from, for example, axle sensors on the tracks, detecting the position and location of each train. That's going to be actually transmitted back through to the 4 and 5G networks. So when the cars and trains, and I guess potentially all the buses and all of the transportation infrastructure are actually sharing the same network, there's the potential to have real-time integrated information so that you can be sure that your bus will meet the train will meet the bus, the car will be able to get there and find a parking space in time, so you can also board the train to complete your destination. So we're seeing everything coming together now over unified 5G network infrastructure, where you have combinations of guaranteed bit rate on contracts that the transportation companies will actually negotiate directly with mobile companies, coupled and enhanced with best effort communication services that allow them to be able to layer on some of the, maybe richer entertainment type experiences on top, which require more network traffic, but are less safety critical.
Thank you, Damien. Christine, a question for you. This is calling upon you to speculate, but how do you think connected cars will affect insurance pricing and costs?
It will, for sure, while we will be able to manage and to know how the driver behavior, if we may say, we will have some direct impact on insurance. So for sure, the insurance company will adapt their services according to more information they will be able to gather. But this is also part of personal data, so they will have to be careful on information they will rely in order to adapt their traffic. So for sure, it will have an impact on the way the insurance will price their services, their insurance services, because they will gather more data from the car, but also the driver behavior. So for sure, there will be some impact on the way they will price, and on the maybe it will be a different services that they will propose to the driver of the company, because they will be able to monitor much more information that they can do today.
Hey, Don, I can imagine, I can chip in here. I can imagine intelligent agents running on the vehicle, giving you real-time feedback on your driving style, warning you how, do you really want to enjoy going around these country roads at this speed, or do you want to keep your insurance premium lower? Getting a real-time alert on exactly what the impact is of your driving style at that moment.
Of course. Another question from the audience. I'm not sure to whom to address it, but I'll ask it first. I believe the connected, this is from Burak Ersoy, apologies if I mispronounced your name. I believe the connected car idea is quite apparent. My question is, who will pay the money to make this seamless micro latency with ultra high frequencies? A simple calculation advises that we have to multiply 100 times the network units to create continuous coverage compared to 4G. Christine, do you have any thoughts on that?
I would say the mobile network operator that will deploy 5G networks. And for sure, it will be the investment that they will have to do in 5G deployment, network deployment, will be paid by the people using the network afterwards, clearly. But I think the investment will come from the mobile network operators themselves.
Investment
Go ahead, Damien. Sorry.
in the infrastructure, I think, will come from the mobile networks, but it'll be clear, I think, for the added value services that the drivers, the owners of the vehicles will be expected to participate either through accepting something which is favoring companies sponsoring those services, or because they want to enjoy those services themselves. So I think one of the things that we're seeing is the cost of all of these services is coming down tremendously, and mobile operators are going to have to be investing more and more in order to stay in the game.
Damien, we have about 30 seconds left, and my question for you is back to your presentation, what kind of vehicle health analytics were you really looking at there?
Well, we've actually been working and talking with a number of car companies that are looking at in the electric vehicles and the life and health of the electric batteries. So that's one of the areas that I've been looking at me and my colleagues. But you could look at all elements of vehicular health. Just that a lot of these electric cars now are also leading the way in terms of next generation communication, next generation computing capabilities, as they are very much, the uber smart connected device.
Thank you, Damien. We're at the 1 hour mark, so I'd like to thank everyone who participated today. As soon as the webinar closes, you will receive a survey on screen, and we hope that you can spare a few minutes to provide us with your feedback. Your feedback is quite valuable, and we use it to shape future webinars. Have a wonderful morning, afternoon, evening, or night, depending on where you are. Thank you.